Welcome to Curious Tech, and we're starting the Rust with Me series. So what I'm going to do is I'd like to learn the language Rust, Rustlang. It's been a language that I've had my eye on for quite some time. So I'm going to take some time to learn it, and I decided to do this almost like live stream vlog style, where I'm just going to go through the main Rust book. It's literally what it's called, the Rust book. I'll have the link in the description, and what I'm going to do is just go through it a few chapters at a time, record it, and put a whole video series together. This is not me looking at this as an expert. I don't know Rust, so I'm going to be coming at this pretty cold. But what I'll do is I'll go through it, and those who are interested can follow along. Depending on what I see, I'll call it out. We'll see what's interesting. You'll be able to see my screen as I'm going through this, and you'll see each chapter. I'll also have a repository with all the code as well, so if you're going along, you'll see the different commits into that repository. Alright, so let's get started. I have the book up here, and we'll see how far we can get in the first session and go from there. Alright, so this is the foreword. So they say in the language here is about empowerment, which is good. I guess that means enabling you, the user, to do more, make you feel comfortable doing more, reach farther. Okay, that's not a strong term there. Variety of different domains than you did before. Okay. They consider this a systems level language. Cool. That deals with low level memory management, data representation, and concurrency. Traditionally seen as arcane, takes lots of years to learn, infamous pitfalls, less code. So, I think they're pretty much implying C and manual memory management with this. So not managing your memory, hitting out of bounds memory errors, corruptions, those kind of things. So Rust is trying to help you write applications that you traditionally might consider writing in C, particularly for speed, or for the low-level systems access, but you should be able to do it in Rust. Polished set of tools. The language I used most recently that had really good tool chain is Golang. They had a lot of tools along with it that just came with the language by default. Not everything, but a lot of things you needed. So I'll be interested to see how the tools parts work here. And not just a low-level language. You can write CLI, web servers, infrastructure code, APIs, etc. Who's Rust for? And people who value speed and stability. It's a good combination. I value those things. Ease of use, maintainability, easy to learn, other things I value. So, okay, how to use this book. All right, let's talk about this. In general, this book assumes you're reading it in sequence from front to back. Later chapters build on concepts from earlier chapters, and earlier chapters might not delve into a detail on a topic. We typically revisit the topic in a later chapter. So some things they might gloss over and just show us because they think they're going to do it again later. You'll find two kinds of chapters in this book: the concepts chapter and the project chapters. In concept chapters, you'll learn about an aspect of Rust, and the project chapters will build small programs together, applying what we learned so far. So chapters 2, 12, and 20 are all project chapters, and everything else is a concept chapter. Interesting. An important part of the process of learning Rust is how to read error message with the compiler displays. It will guide you towards working code. As such, we'll provide as many examples that don't compile. Along with error messages, the compiler will show you in each situation. Know that if you enter and run a random example, it may not compile. Good to know. Make sure you read the surrounding text to see whether the example you're trying to run is meant to return an error. Ferris, I guess this little crap thingy, will also help distinguish code that isn't meant to run. Question mark doesn't compile. Panics doesn't produce the desired behavior. In most situations, will lead you to a correct version of any code that doesn't compile. And source files from which this book is generated is on GitHub. Cool. All right, so we're officially in chapter 1, and we are going to start the Rust journey. I'm on a Mac OS machine, so various things I do will be related to that. This is something I skipped. I already have Rust installed. I've already got Xcode installed. So let's check this. Now there's a copy button here. Looks like it found a new version and is pulling in the updates. Yeah, so I went from Rust 1521 to 1581. I think it had dates in here too. May 2021 build to a January 2022 build. Cool. Alright, and I'm pretty sure that worked because it just told us what build number we have with the dates that it's telling us to do here. Does that pull the $sign? Yeah, that kind of defeats the purpose of copy. I mean, I might cut a small CR. I don't know, to see if they're willing to remove that. Like, what's the point of the copy button if you're going to pull the terminal prompt part? Alright, what we expected. Okay, looks like it comes with the documents too. So let's see what happens. Rustup doc. What's up, doc? Look at that. Instantly caused my browser to open right here. What did it do though? Rust documentation. Looks like no. The Rust book. This looks similar, but doesn't look like. This looks like it's got examples, like the actual documentation. I think this looks like, alright, yeah, that's what I'm doing. Yeah, so it looks like right now I'm pulling it off the internet. Like, it looks like by doing this, you can pull it up locally. And it didn't start a server. It looks like it's just literally opening files. So it just opened to the path of where this is installed. So it's always on your machine, like rustup dropped it here as a compiled document. So if you're on a plane, whatever, if you know the path, but even if you don't, you can just run rustup docs. What did I do? I set this to 150. Just use the same thing. Alright, so installation. Oh, that's going to be annoying. Does this do that? It does not. Okay, so I'm not using the documentation here because it doesn't record the zoom size I have. Looks like they have Rust by examples here. Ooh, nice. So when I was learning Go, they had a Go by example page, and I still use it every so often just as a very quick reference for something. If I just have a brain fart, can't remember something, go by example and just look for that one specific thing, and then learn about it with a quick example. I think Go by example could link to like an interactive web browser that was running Go with the same code, so you could literally run the examples as well, but still. Rustlings, okay. Yes, we should look at the standard library. Reference. So this is a goal, is to basically cover a lot of the more in-depth components of Rust, it looks like. The dark arts of unsafe Rust. This is interesting. I'll probably need to come back to this. I've been hearing that if you're using Rust for embedded development, then you'll need to use a lot of unsafe operations. So curious about what's here. Back to that. Oh look, embedded Rust sitting right here. Okay. So bottom line here is there's a bunch of documentation. I believe everything I clicked on going forward is all on my machine. Yep. So that's cool. Definitely like wins with the plain use case. You can just rust up, pull up the documentation, which is also like fascinating. Like you could be working on a Rust app locally, can't remember how to do something, and all the docs are here. Like, I mean, I was getting down into the weeds in embedded Rust in the documentation, standard library information, extensive platform documentation of what the different components of Rust are intended to do. So that's cool. This book assumes you're familiar with the command line and makes no specific demands about your editing or tooling. This code lives. Per using IDE instead of command line for free. Many IDEs have Rust support. So I'm going to do a couple of the examples, probably just the first one or so from my terminal. And then I'm going to jump to JetBrains CLion, and I'm going to use the Rust plugin that I have here. Probably show that I already have it. Yes, Rust plugin is installed. Doesn't look like there's any updates. Then plugin, markdown plugin. That's it. So let's see. I've already turned this into a Git repository so I can push what I've done later. I think I did the Git repository at the Rust book level. All right, and then I'm just going to go ahead and follow the documentation. Enter projects. And actually, my terminal's apparently going to get long. It wants me to call it main.rs. Does that look right? Print line, hello world. So I guess rust compile. Command C compile, yeah. It's doing something. Now I have a main. Bam, hello world, first Rust program, knocked out. Okay, regardless of your operating system, hello world should print from the terminal. If you don't see the output, refer to troubleshooting part of this program prior to this. If hello world did print, did a first program. So what do we do? First piece of the puzzle is main, okay. The main function is special. It is always the first code that runs in every executable Rust program. The first line declares the function name main that has no parameters and returns nothing. Alright, so we ran this and we got our hello world. So we know that's running. And it kind of mentions that, hey, unlike a dynamic language, once you compile it, you can just ship it off to a machine that doesn't have Rust installed whatsoever, and just use this. Again, I mentioned Go, since that's the last language I learned recently, similar concept. All right, let's take a look at cargoes. Let's see what this is about. So, built-in package manager, nice. Okay. We don't have any dependencies right now. Most things use cargo, so the book's going to reference cargo. Looks like a typo. Okay. Looks like it matched my Rust version. Alright, so let's do create a project with cargo. Interesting. Okay. So we created a cargo crate, I guess. Let's see how it differs from my original hello program. So we're in the directory now, and you'll see that cargo has generated 2 files, the toml and the source directory. It also has initialized a new Git repository along with a git ignore. Git files won't be generated if you run cargo new within an existing Git repository. You can override that behavior. So cool, so you don't have to use get either. So I mentioned I already was in a Git repository, so it's not gonna, looks like by default it's not gonna try to make a new Git repository. Haven't done anything yet. Yeah. Basic thing. It's basically what it says it's going to do here. It's got a comment about, you can look at the .cargo reference, which probably exists on this machine as well. Alright, so you got the package section, the name, dependencies. So first line package, this includes heading, the sections. The appendix has more details. Dependencies is where we list other crates that we need. Next chapter we'll use some crates. So let's open this. It says there's already a file in source and it's already filled out. It is true. We wrote a program for you just like the one we wrote. So far the difference between your program and this one is that we have it in the source directory and we have a configuration file. Cargo expects your source files to live inside a source directory. Top level project directory is just for README, license, configuration, nothing else. Cargo is used to organize your projects and place everything in its place. Okay? Building and running a cargo project. All right, so this seems like cargo build. Let's see. Let's see what we got next. Quick and easy. Maybe that's something got cached from the earlier build. I guess the question here is, did it actually even build the, oh, thinks it did. So, did it build the Rust main? And it looks like it did it as name of the cargo crate. Maybe targets are done. Yeah, okay. I wonder if it matters where you run this from. It says do it from the hello cargo directory, which is here, but I didn't do it. I did it inside the source directory, but it still made this target directory. Bam. So that's interesting. Okay, I'm assuming that it would have had dependencies here as well in this log file. Cargo build, cargo run, cargo check. Yeah, the only difference at that point, oh, I didn't say this out loud, but basically you can do cargo commands on any OS, so it should figure out what to do and where to put stuff. And the only time it'll matter, oh yeah, if you use cargo run, then you can run the program versus having to do path specific stuff, which I don't think I tried. Did I try cargo run? I don't think I did. Yeah. Yeah, I ran it myself. This time I did cargo run, so like it did the compilation. In this case it was already compiled. I just ran it. So cargo check periodically to make sure it compiles. Cargo build when they're ready to make an executable. If you build and run using that. So if you provide a project and check error using cargo check, so that way we don't have to binary create it. Still looks like there's some opportunity to use git ignore, just to make sure you don't pull extra stuff into the version control. When your project's ready to release, you can use cargo build release to compile it with optimizations. This will create an executable in the release folder. I think before was making them in the debug directory. Yes, that's what it's saying here. Optimizations make your Rust code run faster, but turning them lengthens the time it takes for your program to compile. This is why there are two different profiles, one for development, so we can get a faster iteration. So let's see how long this takes. It was taking like a half a second to do that kind of stuff before. %50 more time, I guess, or a third more. Went from like 0.6 to 0.8, so like a third more. Cool. So with simple programs, Rust is fine, but more complicated programs, cargo. I don't see any reason why you wouldn't use cargo given what it does. It seems like there's literally no reason not to use cargo. It'll make the directory, it'll give you your main file, it will create your toml, you can compile it, check it. It seems like my default is just going to always be to use cargo. Right. You know, this pretty much is referencing again what I just said, which is just use cargo. Doesn't really seem, looks like cargo has its own documentation. Have to dig into that later. Yeah, so cargo has its own book. Oh, interesting. We may need to dig into this, particularly to understand how tests dealing with continuous integration. Oh, they have examples for Travis CI, GitLab. Awesome. That means chapter 1 is complete.